You ever wonder, what are the odds it's going to rain today? Or what are my chances of actually winning this game? Heck, how likely is it that a medical test is even right? The thing is, we're surrounded by uncertainty just all the time. Well, probability, that's the language we came up with to make sense of it all. It turns a wild guess into a number we can actually work with. And today, we're going to build your very own probability toolkit. By the end of this, you'll have the power to make sense of a world that's, let's be honest, pretty unpredictable. So here's our roadmap. First, we got to learn the lingo, the language of chance. Then we'll dig into the three big logical tools, or, and not. Finally, we'll put it all together and see how this complete toolkit helps us figure out the real world. You know, these questions might look almost the same, but that one little word, changing or to and, completely flips the script. It's a totally different problem. Understanding why is the absolute key to unlocking probability, and that's exactly what we're about to break down. All right. Before we can start building anything, we need to make sure we're all speaking the same language. Every field has its own jargon, right? Probability is no different. So let's get the basic terms down so we're all on the same page. First up, an event. This sounds fancy, but it's really just the thing we care about, the thing we're trying to measure the odds of. It could be super specific, like rolling a 5. Or it could be a group of things, like drawing any of the 4 kings. It's our target. Then there's the sample space. This is just the universe of everything that could possibly happen in a situation. If you roll a die, what can happen? You can get a 1, 2, 3, 4, 5, or 6. That's it. That list of 6 things is your sample space. Now this one is super important, mutually exclusive events. All this means is that 2 things can't happen at the same time. It's impossible. If you roll a die and get a 2, there is no way you also got a 5 on that same roll. One outcome excludes the other. It's one or the other, never both. Okay, don't let the symbols on this slide scare you. This is basically our decoder ring. It translates all that math speak into plain English. So when you see P of A, that's just a fancy way of saying the probability that event A happens. That little dash next to the A, the prime, that just means not A. Simple. And these 2 symbols, the U shape and the upside down U, they're the big ones for today. The U, or union, means or. The upside down U, intersection, means and. That's it, or an and. This is the key to everything we're about to do, so let's lock it in. All right, we've got the vocabulary down. Time to grab our first tool from the toolkit. This one's called the addition rule, and it's all about tackling those or questions. You know, what's the probability that this happens or that happens? And this is a perfect way to visualize the 2 different flavors of or questions. On the left, you've got 2 separate circles. They don't touch. That's because the events are mutually exclusive. They can't happen together. But on the right, the circles overlap. That overlap is where both events can happen at the very same time. So here's the crucial difference. If the events can't happen together, if they're mutually exclusive, you just add their probabilities. Simple as that. But if they can happen together, you have to add their probabilities and then subtract the probability of that overlap. Why? Because otherwise you'd be counting that middle section twice, and your answer would be wrong. And this card example makes it perfectly clear. Okay, there are 4 kings in a deck. There are 13 hearts. But if we just add 4 plus 13, we've made a mistake. We've counted the king of hearts twice. It got counted as a king, and it got counted as a heart. So we have to subtract it once to get the right answer. Makes sense, right? Okay, we've nailed or. Now let's grab the next tool, which is all about the logic of and. The multiplication rule helps us figure out the chances of 2 or more things happening together, or one after the other in a sequence. So the first kind of and problem involves independent events. This just means that what happens in one event has absolutely 0 effect on the next one. The classic example is flipping a coin. If you get heads the first time, does that change the odds for the second flip? Nope, not at all. The point doesn't remember. The 2 events are totally separate. Now here's how we handle them. For independent events, it's easy. You just multiply their probabilities together. But for dependent events, where the first outcome changes the odds for the second one, we have to tweak it. We multiply the probability of the first event by what's called a conditional probability. That PB/A just means the probability of B happening, knowing that A already happened. And drawing cards without putting them back is the perfect example of dependent events. Think about it. The chance of pulling a king on your first try is 4 out of 52. But once you do that and you don't put the card back, the whole deck is changed. Now there are only 51 cards left and only 3 kings.
So the probability for that second draw completely depends on what happened in the first.
You know, when sequences get longer, something like this tree diagram is an amazing tool. It helps you visualize every single possible path. Each branch is an outcome. If you want to know the probability of a specific sequence, like heads, then tails, then heads again, you just trace that path and multiply the probabilities you see along the way. Super handy. So we've got tools for or and. But our last tool, the complement rule, is my favorite. It's often the smartest and fastest way to solve a problem. This isn't just another rule, it's a brilliant shortcut that can save you a ton of headaches. And the logic behind it is just beautifully simple. I mean, think about it. For any given event, it either happens or it doesn't. There's no third option, right? So their probabilities have to add up to 1 or 100%. This means if you know the chance of something happening, you instantly know the chance of it not happening. You just subtract it from 1.
Okay, this is where the complement rule really shows off. If we tried to solve this the long way, man, we'd have to calculate the odds of getting exactly 1 head, then the odds of 2 heads, then 3, then 4, then 5, and then add all of those up. It's a huge pain, and it's so easy to mess up. But there is a much, much better way.
And this is why the shortcut is so awesome. Just ask yourself, what's the opposite of at least 1 head? The only other possibility is getting 0 heads, which means getting all tails. In calculating the odds of 5 tails in a row, that's super easy. We find that one probability, subtract it from 1, and boom, we're done. It's clean, it's fast, and it's just a way more elegant way to get to the answer.
So there you have it, the addition rule for OR questions, the multiplication rule for AND questions, and the clever complement rule for NOT questions. These 3 rules aren't just separate ideas. Together, they form a complete system for thinking logically about an uncertain world.
And this isn't just for games like cards and coins. In the real world, these fundamental rules are the building blocks for solving incredibly complex problems. Engineers use them to figure out the risk of a bridge failing. Doctors use them to understand how accurate a medical test is. Geneticists even use them to predict the odds you'll inherit certain traits. It's everywhere.
This quote really just nails it, doesn't it? Probability isn't just some abstract corner of mathematics. It's a powerful framework for reasoning. It gives us a structured, logical way to look at risk, to make better predictions, and to navigate a world where, let's face it, almost nothing is a sure thing.
So that's your toolkit, the fundamental logic of OR, AND, and NOT. These aren't just rules to memorize for a class. This is a new lens for seeing the world around you, a world that's full of uncertainty, but an uncertainty that you now have the language and the logic to start to measure.